Hi everyone. So I don't actually have that much trouble saying no to things that I don't think I'll enjoy. At least I think I am. But saying no to things that seem awesome, I'm exceptionally bad at. And that's why I've had a to-do list with personal projects beside my laptop since December of 2014, when I discovered my passion for the visualization of data. I do cross things off every now and then, but new items appear just as fast. But in hindsight, I don't mind this permanent lack of having enough free time left to actually get bored. And I think they really helped me find opportunities that I didn't even know I was looking for. And they also played a really big role in me being able to pursue a freelance career 3 years later. And my favorite personal project is the one that I want to talk to you about today. It is a year-long collaboration that I did with Shirley, who is, like me, a freelancing data visualization designer, although she's based in San Francisco and I'm from Amsterdam. So to set the scene, a bit of background. Shirley and me first met virtually in a DataVis Slack channel, and then met online in real life actually, a few months later at OpenVisConf, where we both had the honor to speak, and we really hit it off during those 3 days. So a few weeks later, I was publishing tutorials about the different aspects of my talk, and Shirley really jumped on them and started asking me all kinds of questions. And somewhere during those chats, we started lamenting the fact that we hadn't created as many more advanced data visualization projects in the previous year as we wanted to. We've been busy doing other things, tutorials, workshops, blah, blah, blah. So somehow, out of the blue, Shirley asks me, well, do you want to collaborate and create stuff? And I think it took me mere seconds to reply with an all-capital yes. And that's how Data Sketches was born. So in the following week, we figured out that we both liked the idea where we would create a visualization each month around a specific topic and do that for a year, to see how two people would create two visuals, starting from the same seed, but then diverging in different paths based on our own interests and history. And besides sharing this end result, we also really wanted to write about the creation and design process. And we split that up into the 3 pillars that we find most important: data, sketching, and coding. And initially we thought we could pull data sketches off with about 5 to 6 hours a week. But as usual, real life really doesn't care about plans, especially coding plans. So since starting in July of 2016, we've clocked many, many hours into creating our visualizations each month. And during this talk, I'd like to take you through some of the lessons that I learned, challenges faced, and the insights that I gathered along the way. So to start off with the most fundamental aspect of data visualization, the data itself. So we often get the question, how did you find your data? But it's not typically the data that leads us. It's the topic of each month that first provides a spark of an idea, an insight that we might want to reveal, and how we would visualize that. For November, for example, the topic was books, pretty broad. But I really wanted to focus on fantasy books, and even more specifically, the themes and titles of fantasy books. That gives you something to search for. So after I know that more concrete angle, I do nothing more special than just Google the web, using my more specific idea combined with the words data or dataset, and then having the patience to click on every link on the first 2 or 3 pages of results. And this has led me to Google spreadsheets containing thousands of rows of Olympic medal winners, or GitHub repos with wonderfully unique data sets, such as one about all of the words spoken in the Lord of the Rings movies, and another one that contains a family tree of 3,000 people connected to royalty, going back more than a millennia. I've also learned that website design says nothing about the quality of the data it shares. So there are also websites that contain structured information, but not in some ready-to-download format. Instead, I have to scrape the logical layout of the website and put the information that it contains into a file with the help of some code. It's not time for the music yet. So IMDb has an advanced search that returns a list of movies. And each of these movies is contained within the same set of divs and other elements in terms of styling. So I can therefore download the HTML structure and then use a script to search for all of the results that follow a certain styling. An easy example, all of the movie titles could be contained within a div of a class title. And another example could be that on Amazon, I was able to find a list of the top 100 best-selling fantasy authors. Well, there are also APIs from which you can request information, but I have to admit I don't often use these because they can be a bit of a hassle to set up. Nevertheless, the wealth of information can sometimes be too good to ignore. So using those 100 names that I scraped from Amazon, I then used the Goodreads API to request the information of the top 10 best rated books of each of these authors, gathering info about the number of ratings, the average rating, and of course the titles of these books. Another way to actually get data is to just ask others for advice. So for April, our topic was community, and I really wanted to do something about Earth, something that would kind of fit the World Wildlife Fund. But I couldn't get my angle any more concrete than that. So I just asked on Twitter, and I got a lot of interesting links, and then I started browsing, which led me to new links, and so on, until I finally came across this. And what you see here is the greenness as measured from space on a particular week in June. And when I saw this, I knew I'd found my hook. I wanted to visualize the same information, but then animate it smoothly throughout the year and try my own spin on the visual styling, which eventually turned into this result. And although it proved technically quite complex because it was a lot of data, the visual itself is very minimalistic. And I think that a title and a simple legend are enough for most to understand what they're actually looking at. Well, finally, you can also create a dataset completely manually, no code required. For our nostalgia month, I dove into Dragon Ball Z. And I'll get back to the visual later, but I could find these lists on the Dragon Ball wiki pages that contained all of the fights that happened during this anime. So I just copy and pasted these lists into Excel and split them apart into the characters and other information. It took me about 2 hours for 200 fights, which I still think is faster than if I tried to create a script to handle all the nuances in the text of these lists. Or when I really tried, and I spent 2 hours finding a proper data set on the characteristics of butterfly species. And in the end, I had to resign myself that the best option seemed to be contained within a website called Gardens with Wings. Again, I felt that scraping this sort of semi-structured website would take more time than the manual approach, so I just clicked through every option and put the information that I needed into a final file of 87 different butterfly species. So what I hope to have shown you with all of these examples is that there's not just one specific way to find data. It's not just hardcore data analysts that have these magical skills. Data can be found in so many different ways, from Googling and finding the straightforward CSV or Excel file to scraping it or even creating it yourself. But be aware that you often still have to do some manual adjustments and preparation to get it into the right shape that is needed for your visual. So to get a bit deeper then into what those kinds of adjustments can be, during August our theme was the Olympics because we are both big fans and it made a lot of sense. And I ended up visualizing all 5,000 gold medal winners since the very first games in 1896. So each of these circles here is a group of similar sports. We have water sports and ball sports, and each slice or feather within a circle. Oh, wow, that went really fast. Let's try that again. That's better. All right. So each feather is an actual sport, and from the circles we have the first edition on the inside going out to 2016. Oh, no way. And then on the reddish background we have the female events, on the blue background we have the male events, and finally each medal itself is given the color of the continent in which the country lies that won. So Europe is blue, Americas is red, Africa is black, and so on. And I found the data for this piece from 2 articles published by The Guardian for the 2012 games in London. And after getting a rough shape of the visual on my screen, I noticed that some very obvious medals were missing from 2012, like hockey. So suddenly my confidence in this data set had dropped drastically, even coming from such a respectable source. And I had to get a sense of the overall accuracy. But I didn't want to have to manually check all 5,000 medal winners, so instead I found a proxy. On Wikipedia, I could find lists that contained the number of events that had occurred during each edition, which I then compared to the number of gold medals I had in my dataset. And if there was a discrepancy, I investigated further to figure out where and why. And that's how I found out that for some of the editions, the horses were also in the dataset, which makes for an interesting read to suddenly see Princess and Sissy and Lady Mirka as women winning gold in the Olympics. Well, eventually I managed to figure out each discrepancy and making adjustments to get it to the point where I trusted my data again. So the lesson here was that you should really get a sense of accuracy and completeness of your data, because missing data can be harder to find than wrong data sometimes. And you don't have to check every value, but think about taking sums and averages and counts and comparing these to plain common sense. Can it be higher than 100%? Does that make sense? Or even better, a different data source. Well, going down a bit deeper into data preparation and how this can be connected to creating more exotic or unique visualizations. So these standard bar and line charts are so straightforward and normal that you can create them with any tool that lets you do data viz. You simply supply the data and the tool or program does the visual heavy lifting for you, creating axes, scales, and so on. But the more that you start to deviate from these standard charts, the more that you'll have to supply other aspects of your visual as well, such as where on the screen should the data be placed. And in essence, the Olympic Feathers project is really just a whole lot of rotated and stacked bar charts. They all follow the same structure and concept, but they also depend on each other. At first, I tried to calculate all of the initial rotations of the circles and feathers in JavaScript, but after having written 30 lines of code and still not achieving something I knew I could do in 2 lines in R, which is my favorite data prep and analysis tool, I just pulled all of these preparations into R as well. So even if they were so-called visual variables, by which I mean that they have nothing to do with the data, but only with how it's laid out on the screen. So I pre-calculated the initial rotation that each of these circles would need to have so that eventually the center would be at the bottom, and how far each of these inner slices would have to rotate based on their predecessors. The only placement variable that I kept calculating in JavaScript to keep it dynamic was the year scale from the center outward, because then I could shrink and expand the circles based on their screen size. But even each metal's offset from the center is something I calculated beforehand. So even if they have nothing to do with the data, it's perfectly fine to pre-calculate these visual variables and attach them to your data. Sometimes, well, it's actually quite useful for fixed data sets, and the reason is that sometimes it's just way easier to calculate these values in a different tool than the tool that you're ending up visualizing it with, such as JavaScript or Tableau. For those visuals that end up in the browser, it can save you a lot of browser calculations, making the visual faster to load. And a personal benefit is that it makes for a lot more readable JavaScript file. So since starting, Shirley and me have filled many pages of our notebooks with sketches because it helps us think and lay out ideas beforehand. And my sketches are often very simple, only focusing on the main abstract shape that I want to fit my data into. Now, colors and layout and details, these are things I only vaguely think about but don't act on until I have the data on my screen. There's no use to spend any time on thinking on these things until I figured out that the shape will actually work once I've put the data into it. So for the Olympics piece, I was inspired by the shape of a peacock feather, placing emphasis on the more recent editions. But I had no idea if that would look all right once I finally placed all 5,000 medals together, so I had to see if the general shape would work before moving on. And it took a few tries to get it to the point where actually things started to make sense, but I saw that luckily it did show potential with the actual data. But networks are quite tricky. You can't really create an abstract shape any more complex than just circles connected by lines. Because for networks, the visual form that works best is so inherent on the actual connections that are in your data. And for October, I went into royalty. I've always been intrigued by how intermarried the royals really are. You know, are they all cousins, twice removed? And luckily, I found this genealogy data set that contained a gigantic family tree of the European royal houses. It was from 1992, so I had to add 1 or 2 more generations in the main line of succession, which was a fun night on Wikipedia. But here is the end result with the 3,000 people. So the current royal leaders are the bigger circles, and everybody's connected to their parents, their partner, and their children. Oh, come on, work with me. And you can hover over a person and then see how far their 6 degrees of separation reaches into this web. And it's just not working right now. I feel it's just hating me, my laptop. They should go a bit faster. Anyway. You can click on a person and any other person and then see sort of how many jumps it takes to get from one person to another person, because this entire web is connected. So everybody in the European royal families is family, in a way. But when I started out with this data set, I had no idea what it contained. So I just placed all of these people on the screen using the most basic network settings. And then this happened. It's sort of an explosion of points and lines moving out of my screen. So, all right, let's rein in that gravity a bit, because these networks are often simulated by using gravity. And, well, then I was left with something that's in network analysis called a hairball. It's quite useless. Well, maybe I can color all of these people by year of birth. That wasn't really helping either. But thankfully, in a browser, you can have gravity depend on a variable. So I pulled the web apart by year of birth as well, which was a little bit more interesting, but it was still a rather uninsightful bundle. And at this point, I'd already invested several hours into playing with the network settings, trying different kinds of connections and adjusting my data. And I was really ready to just give up and try a different angle, like how much are the royals spending these days or something. But I gave it one last shot. And that's when I decided to focus on the current royal leaders. So I placed these in a line, and then I let the vertical gravity depend on which of these leaders you were most closely related to. And that's when I finally saw it in size. For example, that the Queen of Denmark, who's moving around here somewhere, is actually very, very central to the web, whereas the Prince of Monaco line, which is appearing here now somewhere, his line separated from the rest of Europe almost 200 years before. He'll get there. And it was only around this time that I finally started worrying about the more of the design aspects. And networks often remind me of constellations, and with my astronomy background, I have a bias for all things space, so that's why I turned it into a starry night. But I could have never designed this visualization beforehand in Illustrator. I had to go hand in hand with the actual data and apply my design choices to all of the data simultaneously to make sure that the final result was both engaging and insightful. But getting back to actual sketching, for September, I made my most personal data visualization ever. Our topic was travel, and I thought, well, I'll make a visualization of all of the vacations I've ever been on. So with the help of my parents, and browsing through all of my analog childhood photos and my travel journals, then I managed to create a list with a variety of info about my vacations. And initially, I wanted to do something very simple. Just a row for every year that I've been alive, and then colored blocks on the periods when I was on vacation, where these blocks would be decorated to give an idea of where did I go, who I was with, how much did I enjoy it, and so on. So I drew this sketch around that idea. But when I looked a little bit more closely to the sketch, I suddenly noticed that my mind had glossed over something rather important. Namely that I'm only on vacation for a max of 4 to 5 weeks a year, which isn't even 10% of a year. I mean, that isn't bad in general, but in this sketch, it looks more like I'm on vacation for a quarter or a half of the year. So if I were to create this visualization with the actual data, it would be mostly empty, which wasn't what I had in mind. So I drew some new sketches, and in the end, came up with a rather unusual approach. I decided to squish any month in which I hadn't been on vacation. That would make it particularly hard to compare months across the years, but that wasn't my main point anyway. I wanted to visualize trends in my vacations themselves, so from mostly sun-driven in early childhood to culture in my teens and nature these days. And by first sketching things out, it made me realize that my initial idea wasn't going to work, and it guided me towards this new approach. And here is the final result of 30 years of my vacations. But I have to admit that my favorite part of this month was just reminiscing with my parents over old photos and things we remembered from those vacations. And as another example, for the Olympics piece, after seeing an image of a peacock feather, I started drawing some feather shapes. And initially, I filled them completely with color. But while sketching this, I suddenly remembered, wait a minute, the events, they change from edition to edition. So how would that actually work? And the next day, I tried to explain my rough idea to a friend. And again, while sketching out parts of it, I stumbled upon more logical thinking errors that my mind was just glossing over. So only by drawing these shapes several times, catching my thinking errors and trying it again, did I get to a shape that made sense on paper. So instead of going straight from the data or idea in your head to a computer, draw out your design on paper first. It's the ideal way to quickly catch thinking errors. And you don't have to be some sort of artist to do data viz design. It's mostly circles and rectangles and simple curves anyway. The thing is, if you can't make it work logically on paper, it will definitely not work on a computer with the actual data, and it'll save you lots of hours. Well, another thing I try to investigate while sketching is how to add extra details. How to add more context around the main insight that I want to convey. For example, even though the Olympics piece is already pretty high in number of data points, I couldn't resist adding information about the Olympic and world records, because every athlete there tries to break at least the first, if not the latter. So I placed a small white dot on each medal that resulted in a record. So here we have Usain Bolt's 200-meter dash in Beijing, for example. And a way for me to think about adding extra details is to think about the visual channels that are still free after I have the main chart standing. Let me explain that a bit more with another example. So for the past 19 years, during exactly 1 week of the year, more than half of the Netherlands listens to the same radio station. I know we're a small country, but that's still pretty unique. Nevertheless, this happens during the final week in the year when the 2,000 best songs ever are aired, counting down to the new year. And it's quite a thing for a Dutch person, so I asked Shirley if our topic for December could be music so I could tackle these 2,000 songs. And I wanted to visualize what decade was most popular in terms of song release year. And here we have the base visual, where each song is a circle, and they're clustered to sit at the year of release, from the 60s until today. And the size represents the position in the top 2,000, and the darker the color, the higher the position it reached in the weekly top 40s. But you can see sort of that the most popular decade is 70s and 80s, and people are sort of trying to forget the early zeros apparently. But there's so much more information in this data that can supply context, such as song or artist name. But to be honest, I also found the current visual to be a bit boring, so I wanted to add more. And then I think about, well, what visual channels do I still have? Well, here I could add strokes to these circles, or have an extra mark on top, or use annotations. And do a big sketch with some vague ideas of what how that might look. And because in 2016, sadly, David Bowie and Prince died, I wanted to mark all of their songs with a stroke and then tell the people how this had changed with respect to the list of 2015. But I could also use the rankings of these 2,000 songs in different ways, such as who is the most popular band? What song from 2016 is most popular? Which one is the highest riser or newcomer? Or to single out that Pokemon song. It was the year of Pokemon Go. Or to even mark the top 10 songs more clearly by adding something extra on top. And by adding these extra bits of information, I felt that the visual could be more fully understood, enjoyed, and it made for a visually more interesting piece as well. So even if your chart is making the main insight of your data clear to your audience, try and think about adding extra details. To use remaining visual channels to add new variables that can supply context and which can give the truly interested reader even more ways to dive into and understand the information. Well, as expected, most of our time is really spent on getting the data on the screen. And here are some of my perhaps less obvious coding lessons. So for our very first month, the topic was movies. And it was pretty clear to me I wanted to do something with The Lord of the Rings, which is my favorite trilogy. And I thought that with the popularity of these movies, that there would be loads of data to be found online, which didn't turn out to be true at all. But it did contain one true gem of a dataset. Somebody had created a set that contained the number of words spoken by each character in each scene of all 3 extended editions of The Lord of the Rings. How amazing is that? I knew I had to do something with that. And thinking about it, I thought, well, wouldn't it be interesting to see how many words each member of the Fellowship spoke at the different locations in the movies? But as you may be able to see, well, maybe not, there's actually, this is the data set, but there's actually no location information in there. So, with the help of the scripts found online and my own memory of having seen the movies way too often, I manually added location information to all 800 rows of the Fellowship members. Yeah. I drew some sketches, and eventually I came to this idea, where each member of the Fellowship would be placed in the center, and then the locations would be spread around them in a circle, and then they would be sort of connected by these strings, where the width of the string on the outside, represents the number of words spoken by that character at that location. Sadly, this chart form doesn't actually exist, so there's no tool that can help me do it. But it reminded me of a chart that did exist, called a chord diagram. So I thought, well, can I sort of try and see if I can transform a chord diagram into my sketch? And here we have a basic stripped of all text chord diagram. And the most fundamental thing to me was to see if I could somehow make these chords flow towards the center instead, which eventually took less time than anticipated, which is pretty rare for me in coding. Well, getting the actual data in there for the Lord of the Rings, some more appropriate colors, and since we have 9 members of the Fellowship, making sure that the central portions end up at the right location, but this was looking way too squished. So maybe I can pull them apart. Okay, that worked, but now these strings, especially in the top and bottom, were looking a bit odd. And that's when I finally decided to learn how to create SVG paths, because practically all of my visualizations are created using D3, which creates SVGs. And that is the thing that took the longest during this project to actually learn, but it was quite fun. But this looked more natural, I felt. And that's how finally I ended up with this new chart that was mutated from D3's chord diagram. And because we have so many of these strings visible, I thought, well, I need to have some sort of interaction. So you can hover over a location and see the people that spoke there, or vice versa, if you hover over one of the characters, you can see what locations he spoke. But I also added a small piece of insight that I'd found for this character from this data. And my favorite one is actually this one, where Boromir, who is really only alive during 1 movie, still manages to speak more than Legolas does in 3. I didn't know that beforehand, but... And I don't even want to mention how long it took me to try and find the Elfish translations of these locations, and I still don't know if they're correct. It's bothering me. So many people have done amazing things that you can use. And even if you think you're creating something new, you don't always have to start from scratch. Just try and find the thing that most closely resembles your idea or design and start adjusting that. Remix what's out there already. And I guess the thing that I learned most about during that year was SVG paths and how they can be connected to creating so many more possibilities on how to shape your visual. From simple curved instead of straight lines in my royalty network, to sweeping arcs in my visualization about fantasy books, to the feather shapes that I really created for the Olympic Feathers project, but that never made the final cut. And the strings that we saw just now, Lord of the Rings, and these, I don't even know what to call them, radially flowing lines connecting groups between 2 circles. And if anybody has a shorter thing than that, I'd love to hear. And another project that is very much based around custom SVG shapes has to do with our Nostalgia Month. So I decided to dive back into something that I was crazy about during my teens, Dragon Ball Z. And for those that sadly don't know it, Dragon Ball Z is an anime that revolves around fighting. So I thought, well, wouldn't it be fitting to actually make a visualization that shows all of the fights that occurred during this anime, and to show, who was fighting whom and what state were they in, Super Saiyan, and was there anything special about the fight? And here we have the base of the visual. So each cluster of circles is a fight, and they are ranked in order of occurrence. And from left to right is the sagas, which is sort of similar to story arcs or seasons in a way. And to more easily follow a character from fight to fight, I wanted to connect their fights by a line. And since a straight line doesn't really make any sense here, I started out with a collection of so-called quadratic Bezier curves that give you the option to pull on these sort of line sections by moving anchor points. And to make it visually more interesting, I pulled harder on these anchor points when the distance between two fights was farther apart. And then I got some great advice to actually use the side of a fight to denote good and bad guys. So good guys swoosh on the left side and bad guys on the right, which then shows you that for this character, Vegeta, he started out as a bad guy, moved around a bit, and then mostly became one of the good guys. So doing this for all of the characters. And actually this definitely showed me insights into characters that I never really realized, but I just wasn't liking the single thickness lines. They weren't conveying the dynamic nature of these fights. So instead, I thought I need to create a shape that I can fill with a color that sort of mimics a stroke of varying thickness. And as usual, I draw that out on paper, and then I try and deconstruct it in terms of its mathematical, or in this case, SVG path elements, which here came down to flipping the path back up again and using different amounts of swoosh. That's a technical term. And now, with that implementation, I felt that the lines connecting these characters between fights became a lot more visually interesting and fitting. So even though I've been talking about SVG paths here because they are so central to the work that I do, but the main lesson is that you should really thoroughly understand your favorite or the main tool that you're working with if you want to go beyond the examples. So I was using D3 for 2 or 3 years before I finally took the time to learn how these SVG shapes are actually created. And it opened up a whole new world for me in terms of creativity and possibility, so I wish I'd done that sooner. Another thing we had a lot of fun with during the year was math. And here is my addition to our collaboration with Google News Lab. And being a non-native English speaker, I wanted to focus on translations. So what do other languages want to have translated into English by using Google Translate? From the most translated word of 10 chosen languages to the top 10 for these languages, and finally the similarities between these languages. And for the first visual, I wanted to string together these most translated words by a swirling path that would represent the 100 most translated words overall. And preferably, I wanted something organic looking like this. But for the life of me, I couldn't figure out how to create something that would mathematically create a similarly organic swirl and that would update and be responsive to both desktop and mobile sizes. So eventually, I went with the idea of beads on a string slowly zigzagging down. Of course, I still end up making errors in my mathematical functions on paper that reveal themselves once you've coded it out, thankfully. But eventually, I got the layout working, and now using screen size, I can either have it be 4 or 3 or 2 beads wide. And the last visual on the page also proved to be a rather interesting math and logic puzzle to solve. So in it, each word that 2 languages have in common in their translation top 10 is represented by a line. And initially, I wanted to have all of these visuals to be completely built up out of the words themselves. So I wanted to replace these lines by the words they represented. But once I finally had that working, I immediately saw that was one big mess. So I had to compromise and eventually only place these words on the lines connected to a central chosen language. But it's really important to make sure that these words were placed in the most upright manner possible for readability. But that gave quite some convoluted calculations in terms of these text paths on which they are drawn, which became glaringly obvious when you click one of these languages to move it towards the center. Not quite what you might expect and what's going on there with those lines. So I again went to my notebook, and it took a few more pages to figure out how to implement a solution. But eventually I got there, and now it should be working the way a user might expect it to work, although not as smooth in my presentation. So what I'm doing really is more of a hack. When somebody clicks one of these outer languages, I fade out the words, and then I immediately replace all of these lines with their final state but reverse engineer it to look like the initial state, and then smoothly transitioning to the final state. So the lesson here is very simple. Learn to love math, and especially geometry, because they are often your best friends in finding solutions to these visual problems. And I want to end with one of my favorite lessons. During February, our topic was nature, and I'd always wanted to do something more along the lines of generative or data art. And the apparent randomness of nature felt like a perfect match. And it also reminded me of butterflies, how their path also feels kind of random to me. So I wanted to mimic these butterfly-like paths across the screen, and then using data from different butterfly species to guide the appearance. So the species main color would give the color of the path. The species itself would define sort of the line style, and then the wingspan, the thickness of these paths. And then using lots of semi-random number generators, together with inspiration from the works of Jared Harbaugh and Inconvergent, did I let my butterflies free across the screen. And this is the only month in which I make no attempt to make the data insightful. It's really just creating something that is based on data, but that delights its audience, to keep them mesmerized as the screen fills up with more and more butterfly paths. And keeping your audience engaged and delighted is an important factor to keep your audience into the visualization, especially for the more complex ones. And you can do that in lots of diverse and subtle ways. For example, I was once on a flight back to Amsterdam, so no Wi-Fi, and I therefore couldn't really do anything essential. So I just created an animated legend of my visualization about fantasy books more for fun. Other non-essential things that I've added are animated GIFs of the most memorable moments in Dragon Ball Z, or having hovers with the lowest level of information that I had for music nerds in my top 2000 visual, or turning the top 10 songs into tiny vinyls, and having annotations of weird and silly events that happened during the history of the Olympic Games, such as Henry Pierce having to stop for ducks in the rowing event, but still managing to win gold. So even though getting your data on the screen in such a manner as to make it insightful is key, it's the other things to add, such as annotations and animations, weird legends, GIFs, and more, that can make it truly unique and special, and even more of a delight to investigate. So take some time to think about these aspects as well. And then we have collaboration. Maybe one of the best things about it is that you're not in it alone. So even though Shirley and me both created our visualizations separately, we shared lots of things throughout the process. From discussing initial ideas to sharing in the joy of finding an appropriate data set, and of course sending across loads of photos and screenshots of our works in progress. And we started out as two people who sort of knew each other through Slack, and we had a good time at a conference. But in the end, we made an incredible friendship during that year, and we talk to each other practically daily now, and we even work together professionally on our bigger client projects. So if you are thinking of embarking on an ambitious project, I can definitely advise you to search for a partner. I think that partnering up will keep you going more easily. I was always motivated to work another evening on one of my projects when I saw Shirley's screenshots of her progress, but I also didn't want to let Shirley down, so I was way more motivated to stay on track. Although it will be very useful if at least one of you is responsible, so at least you don't both slack off, that it's someone that you respect, and that it's someone that you trust or you think you can learn to trust, because that is crucial in giving and receiving feedback. And even though, no matter how enthusiastic you might be about starting or how much fun you're already having, at some point these ambitious projects will get hard and will require a level of dedication. Try again if you're having a bad day, but at least try again. Because with each new app and visual and demo that you create, you'll learn new skills, and that skills that you can develop even further on your next project. So that's why these personal projects are definitely worth the time investment, in my opinion. So although I've been taking you along on a design journey, through my lessons on visuals, Shirley also made a visualization each month with her own spin on a topic. And here's a sneak peek of two of my favorites. So the first one is her take on our movie month, called Film Flowers, in which she scraped IMDb for the top summer blockbuster movies for every year since she's been alive and turned them into flowers. So each of these elements of the flower represents some value, from the size being the rating, the the color signifying the genres, and the petal shape being the age rating. And by using that technique, each movie can turn into its own unique flower. And I love this project because it creates such a wonderfully artistic output, but you can still sort of hang it on a wall and continue to compare movies across the years. I think that one, Batman and Robin, is her own personal favorite because it is so tiny. And the other one is Hamilton. So even though this was published for our Books Month in November, she had been working on this for 3 months prior to that. That's how crazy she is about Hamilton. And I can definitely advise you to read her write-up of this month as well to see her dedication to the data gathering alone. But as you scroll through this page, Shirley takes you through all the lines of this musical. So how are these people connected, and which songs do they sing together? And she ends by explaining more about the character arc and developments of one character in particular. And I love this project because just a general sense of delight that you feel by scrolling through and interacting with the different elements on this page. And so I can definitely advise you to also search for her other projects because they are each fun and unique and gorgeous takes on our projects. So in that time, I learned that you can find data in the weirdest places, that it's not blasphemy to precalculate visual variables, and that sketching helps weed out thinking errors, but that you can also sketch with code, that SVG paths are amazing and math is too, but I really already do that, of course, and that really small and subtle things can create an overall sense of delight for your audience. We didn't set out to be confronted or learn all of these things, we just wanted to have fun. And in that, we definitely succeeded. And the thing is, actually, even though the year has already come and gone, we still have a month or two to go. There's still a few empty spots there. And that's because even though we were having fun, during the final stretch, we noticed that we'd taken on too much, and we decided to take things a bit more slowly. So, if you want to, you can still follow us in our final month or two of coding and data preparation and munging to turn these topics into fun and weird and often overly elaborate data visualizations. So thank you very much for your attention.